3D, trigonometry and Pythagoras. So we're going to be using a squared plus b squared equals c squared for our Pythagoras. Now you may or may not have seen the following. A squared plus b squared plus c squared equals d squared, where d is the diagonal of your three-dimensional shape. And we're also going to be using SOHCAHTOA. So a combination of trigonometry and Pythagoras to tackle questions involving three-dimensional shapes. The best way to look at this is through exam-style questions. If length A to B is 7.3 centimetres and CH is 8.1 centimetres, angle BCA, so BCA, so we're just going to draw a diagonal from C to A. That angle in here is 48 degrees. Find the size of the angle between AH, so we're going to draw that diagonal in, and the plane. Now the plane ABCD, we want to look at this from top view down. A, B, C and D. We want to look at the angle that the blue diagonal AH makes with the plane, and that is to say with the line CA. So we want to know the angle that AH makes with the plane, this angle here. So what we want to do really is look at this in a number of different 2D triangles. So first I'm going to draw AHC. A to H is our diagonal. H to C we know is 8.1. C to A we don't know the length of. A to H we don't know the length of, but this is the angle we're trying to find out. To find that out, we need to know at least one of the other lengths of our triangle. So now we're looking top down. We've drawn on our A to C, of which we know that our angle BCA, so when we look at it top down, that's 48 degrees, and A to B is 7.3 centimetres. So what we want to look at now is, well, what is common to both triangles? We see the line A to C is common to both triangles, so that is the length we want to find out. Now we know that looking at our square means that we have right angles. So we're going to be using SOHCAHTOA. So here's our angle, which this is the opposite, this is the adjacent, and this is the hypotenuse. Now for this first triangle, we want to find out the length of the hypotenuse, and we know the opposite. So we're going to be using SOH. Cover up the one you want to find out, which in this case is the hypotenuse, leaving us with the opposite, which is 7.3, over sine of our angle, which is 48 degrees. And we pop that into the calculator. 7.3 divided by sine 48, and that gives us a hypotenuse of 9.823 ... We're just going to keep those points, and that hypotenuse is line A to C, so we know that our A to C here is 9.823, etc. Keep it in your calculator. Now we've got our right angle triangle. We want to try and find out the size of our angle, of which we have the adjacent and we have the opposite. Now in this case, it's trigonometry again. We've got the opposite and we've got the adjacent, so this time we're going to be using TOA, where we want to find the angle. So remember, when we're finding the angle, we do the inverse tan of the opposite over the adjacent. So that's the inverse tan of our opposite, which is 8.1, and our adjacent now is our 9.823, the number in our calculator. So on the calculator, shift tan. In the bracket, we press our fraction button and we have 8.1 and we move our arrow down to the denominator and we use the ANS button to put in the value that was last in our calculator. To one decimal place, that's 39.5 degrees. So top tip with 3D trig or 3D Pythagoras questions is to draw them out as multiple 2D shapes. The size of the angle between CH, so let's find CH, that is our diagonal, and the plane, so again the plane is this, is 35 degrees, so this is 35 degrees here. We want to find the volume of the cuboid. Let's recall, volume of a cuboid is length times width times depth. Well, we know 5 times 4 times depth is something we don't know. So we want to find the length of either BC, AD, GF or HE, as they are all the same length, they are all the depth. So let's start with what we can see. We have got a 2D triangle of which HAC 35 degrees, right angle, that was the plane, 4 centimetres. Now we want to try and use a triangle to work then the depth of this shape, so it's trying to spot where another 2D triangle is that we can use. So if we were to work out this length here, AC, and we can treat this as, remember, let's look top down at that base of that rectangle. A, B, C, D. So we look top down, we've got our diagonal AC, we know AB is 5 and we're going to try and find out the length of CB or BC because that's going to be the depth. So that's the one we want to find out. So now we see, well, what is common to both of our shapes? AC, AC. Now let's begin calculations. Triangle number 1, what we have is the opposite, and we want to find the adjacent. So we're going to be using trigonometry for this. Pythagoras is lengths only. Opposite and adjacent means we're going to be using TOA. We're covering up the A because that's the one we want to find out, which leaves us with O over T. So that's 4 over tan of our angle. Pop that in the calculator. 4 divided by tan 35 gives us 5.71 ... Keep those decimals. That's the length of AC. Now we look at our second right angle triangle. We've got triangle ABC, of which it's a right angle triangle. We don't know other angles, which means we're going to be using Pythagoras. A squared plus B squared equals C squared. Substitute in 5 squared plus B squared equals C squared. Remember, C is always that hypotenuse. So 5 squared, 25 plus B squared equals our 5.71 squared, which is 32.6 ... Subtract the 25 to leave us with B squared, which is 7.63 ... We want B, so we square root that to give us 2.76 ... That's our depth. So that's our third length. So now we need to just type that in our calculator. 5 times 4 times ANS button, which carries over our 2.76 and all the decimal places. We get an answer of 55.258 ... We want this to 3 significant figures. So that's our first, second, third significant figure. We do need to round that to give us an answer of 55.3 centimetres cubed.